Hi, in this last session what I want to do is talk about graphs and pictograms, and I also want to talk a little bit about percentages. Basically, graphs and pictograms are ways of pictorially presenting data, and even though they are generally accurate, they can somehow be, sometimes at least, be misleading just because of the way they're portrayed. Sometimes we react to the visual instead of looking at what the visual cue actually means. Graphs and pictograms are important to read properly, and the first thing to do is make sure that the values are clearly labeled. Sometimes we don't have the values labeled, and so we get a ballpark figure of the trends, but it doesn't tell us how deep or steep the curves are, or how big they are in relation to each other. And I'll show you examples of this in just a little bit. Also, you want to look for the scale. Sometimes the scale can be distorted to make things look better or worse than they are. And again, I'll show you some examples of this fairly soon. Let's look at this. Here we have a chart with unlabeled values, and what we're looking at is somebody's boulder time. And obviously what they're trying to do is show that they've gotten faster and faster and faster. And looking at that, we're pretty impressed because it seems to have been going, their time went down, until their 2011 time seems to be, about a tenth, an eighth of what their 2008 time was. And so it looks impressive. The problem is we don't know what the scale is. We don't know if we're talking about impressive by a matter of seconds or by a matter of minutes or even by a matter of hours. And so having that other axis labeled is really important. Now let's look at this. In this case, we started with 54 minutes. And so the first year, it looks like there was about 65, second year 60, third year 58, fourth year 57. And so we see a drop that looks pretty dramatic. All right, and again, it looks like this person's boulder time has dropped significantly. Now again, part of this is the way that it's set up. By starting the scale at 54 rather than higher or lower, actually, it makes the time change look more dramatic. Now what happens if we start the scale from 0? Alright, notice how we do see the times going down, because of course they went down, but it looks a lot less dramatic, okay? Because we're looking at their total time and not basically using 54 as a base. So how this is set up and what's used as a base can really affect at least our impression pictorially of what's going on. So they say a picture's worth 1,000 words. In this case, we really have to see what words specifically this picture or this graph represents. All right, and this, I'm looking at histograms, right? These are bar graphs that go up and down, but this can be the same for histograms that go from side to side, and also for charts that use lines instead of bars. And so, all of this we have to look at, what's the scale, make sure that all the measurements occur, and, what's being compared. Now, let's talk about percentages. Percentages are important because a lot of times people use percentages in arguments, and there are a few things we have to make out. One is we have to find out what this number is a percentage of. A percentage is basically a ratio between one thing and another out of 100. So if I say I scored 80% on the exam, I mean 80%, 80 out of a possible 100, or 80% of the possible points. But what if I say my teaching has gotten 72% better? What does that mean? How did I measure the baseline, the 100% against which I'm measuring the 72%? So when we see a percentage, we need to know what the number as a percentage is. And a lot of times we'll see this. This product works 10% faster, or 20% faster. Or the speed of this internet connection is 300% faster. What is it being compared to? Is it being compared to dial-up? Is it being compared to itself earlier? Is it being compared to other services? Which ones? So whenever we look at a percentage, we have to say, what is it a percentage of? And also, percentages can't be added unless they're part of the same total. So if I were to say, I increased my income by 20% this month, I earned 10% more at one job and I earn 10% more at another job. We really should be measuring that percentage out of our total income so they can both be compared rather than have two different things. So we don't know. If both jobs are 50%, then we've really just raised ourselves by 10% because 10% of 50% is 5% on each of those, so that's 10%. So we need to know, if we add them, we need to make sure they're being out of the same thing. Now, if I say, well, I saved 50% on my gasoline bill because I saved 10% by biking to work of my gasoline bill and 10% of my gasoline bill by walking to the grocery store. Okay, and so therefore I saved 20%. I don't remember what the original percentage was I said, but let's say I make that argument. In this case, since I'm comparing percentage of gas bill to percentage of gas bill, I can add those percentages. So if the percentages are relative to the same total, they can be added, otherwise they cannot. And that pretty much sums up the rest of Chapter 12. So I'm hoping that these 3 lectures have given you a picture of what you need to know for this chapter on statistics. Obviously, email me if you have any questions, and I hope this has been helpful. Bye.